Okay, solar goes like this. The basics of the basics. We do have our east and west, right? And we will have the sun coming up on the east and then making it to the west. It's all good. This is common sense, okay? So when the sun is facing south, in this case south is here, this is north. When the sun is facing south, we have the sun at the peak level, all right? So this concept is important, okay? Because our solar panels, as you guys have in the roof, are built up in a different way and set up with multiple cells. So this is a cell, this is a cell, this is a cell, and so on, all right? Then a solar panel is built up with a positive terminal and a negative terminal, okay? Though these solar panels, they do have a technical sheet. That's the only way they can be in the market. Someone as a third-party entity check it up, this solar brand of panels, and said, okay guys, you give me a sample of those, let me put in the lab, I will simulate that based in some standards, and then the outcome will be the nameplate of the technical electrical details of the panel, all right? This nameplate is also in this technical sheet. Just have a quick roundup, all right? And then you'll be able to discuss a little bit more. So this is 1 unit, okay? So far so good, right? Okay, so this is the peak sun, all right? So, as you may have seen and you may heard before, right? This solar panel could have different ratings in terms of power. Could be, for example, 300-watt panel, all right? Could have some characteristics on the current and on the voltage, okay? We will fill it up, these gaps here later. So, this is a 300, okay? So, how do you take it forward now, right? So, your project has been built up in the sense of having an assessment of how much energy you consume on a yearly basis, right? So, and that is your concept. This is your baseline, okay? So, your baseline says that you consume on a yearly basis an amount of, let's say, 1,000 or 1 million, okay, units of energy, okay? Then our concept as solar in the solar industry is to transfer this amount of expected energy consumption that you want to consume or you plan to consume and bring it up a solar solution that can generate this amount of energy, all right? So the solar energy, the objective could be to match your amount of energy generation. So you don't have to import nothing from DO. We will go to DO in a minute, okay? Anyhow, so I've told you about sun peak hours. I've told you about a solar panel, okay? And I've told you the objective of the solar panel, okay? Now, in going to more detail, when you're going to see these 300 watts here, all right, means what? Means that this panel, under certain characteristics and conditions, can produce 300 watts. And this information has been said and stated to the market in general by a third-party entity. It's not the supplier that says I produce 300, or in that case I would say I produce 500, you produce 100, Raul 400, and you guys will get lost, all right? So though this is 300 watts in certain conditions, and that's in peak conditions, okay? So usually what we say in the solar industry, we say this panel generates 300 watts in peak conditions. So we call this concept watt peak, okay? So good? So far so good. Okay, so what is the conditions that we are referring to, right? So the sun should be at 100 watts per square meter, and this is what we call irradiance, okay? And we should have a temperature of 25 degrees Celsius, okay? And there is a small more technical details, but it's not relevant for you. Okay? So, now imagine, today is a Saturday, sorry, right? Saturday. And then somehow, in the middle of the day, or in the early beginnings of the day, we can have these conditions in place. All right? 1000 watts, sun, and 25 degrees ambient temperature. In that case, your panel will produce this amount of energy, power, sorry. Okay? Good. So now you guys know what is the sun peak conditions. You know what your panel produces under these conditions. Okay? And then you know as well that our objective is to produce this much. All right? This is what you consume without any solar. This is what you will still consume with solar, okay? But now you do have a solar parallel source, right? This is parallel with these ones, correct? So we need to consume these on a yearly basis, and anyhow, our solar system will generate the same in the same baseline, okay? So how do I put another sheet? Can I put one more here? Yeah. Okay, so good. So let me just state our conditions of our solar panel again. This is our solar panel, 300 watts. Actually, yeah, we can go 300 watts long. Let's do one thing different. I will ask you guys to look in the technical sheet that I gave you and tell me what is the power of this panel. Can you see them? It's the yellow highlighted stuff. 325, all right? So your panels in this project is 325 watt peak, all right? Can you please state to me what is the voltage and the current?
37.2 voltage.
Sorry?
The maximum power voltage 37.2.
Let me see. Okay, so you're looking into different concepts, okay? So if you see the small letters, guys, then we will change to there. If you see the small letter, you see that the voltage, you have two types of voltage, right? So we do have open circuit voltage, and we have maximum MPP voltage, okay? So you have two different voltages, all right? So remember when you have here our positive and our negative cables? If I bring a meter under the standard test conditions, which is 1000 watts per square meter, and the 25 degrees ambient temperature, if I put a meter there, all right, under these conditions, you will have VOC. Can you tell me the VOC amount there?
37.1.
37.1 volts.
Yes.
Okay. And the VMPP?
VMPP 37.2.
37.2?
Yeah.
Should be lower, no?
And we have two more columns, the 37.3 and 37.
This is for you're looking into this.
Only these things.
So this power, this is 37.1 is the VMPP, and this one here, 45.8. Okay, so I'll just overwrite here, 45.8 volts and 37.1 here. Okay?
For the 3 to 5, it's
45.8. Okay? So what is the difference between these two? That may be important one of these days when you are in the roof and having a look into voltages and stuff. Okay? In the bottom down of your technical sheet, you have a graph like this. All right? And this is what we call in the industry a voltage, current voltage, so current and voltage. Okay? IV curve. This is what we call IV curve. So usually, if we have our VOC, all right, means that we are at this point, right? Then, now you can tell me also, Opalam, can you tell me also the ISC conditions? I will write here short circuit current conditions and IMP.
9.25.
That's the short circuit current, huh?
Yeah.
9.25. And the IMP?
8.76.
Okay, and this is amps. Okay, we are talking current now.
Yes.
Okay, so what is happening? Can we let's try and identify these points here on the graph. Okay, so if voltage is here, this is voltage, this is current. Okay, when I have my open circuit voltage, what does it mean? If you come with the multimeter and put here the meter, right? I have maximum voltage. Where in the graph we have maximum voltage? At this point. But when is the maximum voltage occurring? When the current is zero. RNA? So you don't have current circulating, means that you are open circuit. Okay, clear? Okay, so this is the 45.8. And this will be the opposite, right? So the short circuit current, when I have a short circuit current, means the current tends to a highest value. Where is this point here in the graph? Here? I would say here, right? Because at this point, the voltage is zero. Correct? All right, so in this case, I have 925 here. Amps. Okay? Now remains two values. Which ones are? The IMP and the VMP. Okay? And when you heard about something MP or IMP or VMP or anything else related to MP, it means that the circuit is operating. We have a closed circuit. All right? So ISC, just to resume, ISC plus VOC refers to open circuit. Okay? Open circuit means I come here with my meter, the circuit is not closed, so I don't have current circulating. All right? In that case, I have this condition. All right? Then I have IMP plus VMP. It's when we close the circuit. Okay? Closed circuit. And when I say closed circuit, means that the circuit is under operation. So, in that case, I will do the opposite exercise now. I will look into the values of IMP and VMP, and I will try to put them here, right? So if 45.8 is here, voltage, our VMP should be a little bit to the left, because this is the maximum value. I cannot go to the right, right? So let's say we have a maximum value here of 37.1. Correct? And that makes sense, right? Because when you are not operating, your values are maximum, right? But when you put the circuit into load, you see your voltage coming down, right? That makes sense. All right. So in that case, we define our VMP now. This is a VMP. And then we just, there's one more value to be defined, right? Which one it is? The IMP, right? If we do the same logical exercise, if 925 is here, 876 should be below. All right? Okay? So, we have identified another point in our graph, which we call MPP, maximum power point. So, under these conditions, okay, your solar panel, under these conditions which are the 1000 volt, 1000 watts and 25 degrees, okay, under these particular conditions, your panel will generate current at the maximum power point level at this point of the graph, which corresponds to the 325 watts. Can you do a simple exercise with me there in your calculator? Can you multiply the 37.5 by the 875? And then do the same here. Right? Okay, this is a simple mathematical equation on a DC circuit, right? Where the power is always equal to the voltage times the current, right? So now the idea is to multiply 37.1 times 8.75. How much it will go? 3 to 4.6, right? So 3 to 4.6. Okay. We are almost there, right? Okay. This is how to share information, how you guys should read that. Because there is 1,000 different models of that. Okay. We will go later to our project. And our project is this panel. Okay. Okay, fine. So, what have we discussed so far? Okay. We said that we create the peak conditions, we define what is a peak sun, and then when the sun is that particular conditions, it could be here, could be at 11 a.m., right? Because usually the sun peak comes at 12, right? But it could be here at 11 a.m., could be at 1 p.m. that you have these conditions. Or you may never have these conditions at site, okay? So we define that conditions, the peak conditions, which refers to these conditions over here. All right. And then we said our solar panel, okay, is built up by a multiple number of cells, okay, and they are electrically joined in series and in parallel in order for you guys to have later on these conditions, okay? These conditions here, all right, or this condition here, let me challenge you for another exercise, okay? Can you divide 45.8 by 72? I will explain you where these numbers coming from. This one you know already. Can you divide this one and let me know? 0.6. This is voltage, all right? This is a number, so means that I have a number by another number, so I have voltage per cell. So, your solar panels in this project, the 325, have 72 of these. Okay? They have 72 square cells. Okay? So, if you divide the VOC, the maximum value, by the number of cells, you will know that every cell will have a 0.6 volt. Okay? You can do the same for current, okay? So, you will know nowadays, by looking into a value like this or a value like this, where if you have a 72 cell or if you have a 60 cell or a 48 volt cell panel, you will be able to know that, okay? So, I will just take this graph to the next sheet, okay? Because this graph is important, okay? And it will allow us to continue our discussion here. So, this is current, this is voltage, this is our VOC, this is our VMP, and this is our IMP, and this is the, let's say ISC, okay? The biggest value, okay? Now we have 4 points in our graph. That's why you have a lot of numbers in that sheet.